It's going fine.
You're in caption. I started taking that and I got completely freaked out and
I don't
I
like
dropped it.
I hated it when I took it,
Yeah,
so
I
I'm
don't
sorry, but you kind of have to take it, right? It's a required course, and
I was
don't
like, I'm
even
gonna have to take it eventually.
and then you're in groups for like the whole second half of the semester, and some of those group meetings can take forever.
I know.
Yeah, I
So
decided to
make sure you have plenty of time for that one.
That's going to be the only one I take at one time, I think.
Yes, it would be wise.
I'll take it all alone. That was I think I was taking 4 classes at the time, and I just about died. So I dropped that one, and then I was down to 3. But I decided I would not do that again unless.
Although I did take that class with an accounting class, which did help out some when we got to some of the equations. So
okay, huh? Well, I've taken my accounting classes, so maybe.
Oh, good.
Maybe I'll be more prepared now than I would have been. All right, so we were discussing, I started the broadcast, and we were discussing some potential ideas for our project. And so, Charity, did you have any ideas?
Not really. I didn't read that much into it. I can't
okay, so we were talking about either fruit by the foot, measuring it to see if they're different. But I think before we decide on that, I think you should open up more than 2 or 3 and see if they're all exactly the same anyway. Because I hate to do it and then have there be absolutely no difference whatsoever.
True.
And then if there are, that's an idea. And then the other idea is we all live in 3 different states. So if we all chose the exact same 40-ish items from Walmart, and we went to Walmart and documented the price or took a picture of it or whatever, secret shopping without getting caught, whatever that is, then we could compare the prices of the 40 items. And I think in the basket of good, it would be good for the 40 items to have, say, 5 in the produce section, 5 in the cheese and milk section, 5 that are maybe hair dye and hair, whatever. But we should get some baskets of goods. I assume you guys have taken economics or are in it or something, but we can maybe we could Google the top basket of goods economically for food and household items, and then base it off that. I don't know. I don't think the random sample has anything to do with. What do you think? Does the random sample have anything to do with choosing our basket of goods?
I think we should stick with grocery items, food items.
Okay.
Not to go off, because if you wanted to focus just on like makeup and hair products, you absolutely could go that direction. I mean, there's tons of things you could go just that direction. So I think we should kind of keep to one category or the other.
Okay, so that's a thought. Measuring the fruit by the foot would be not too difficult.
Could be fun. It'd be really easy and really cheap, I would think, just to buy like a package of fruit by the foot.
I've got kids. They'll just start eating them all and then throw the rest
in. Measure really quick and record and done. So.
All right. So Monica's not on. I'm not sure why, but that's okay. She might join us in a bit. We can start this group quiz.
Okay.
So number 1, true. Number 2, if it saves it. My computer, I'm in a different room and it just goes really slow here. There we go. Okay, go down a little bit. Number 3, if I can get to it. All right, I guess I'll start. In a pie chart, what are the slices? Why are the slices different sizes? The size of each slice is random? No. The size of each slice is determined by the number of categories? No. Each slice represents a category, and the area of each slice represents the proportion of the total occupied by the category? Yes. Pie charts are more visually appealing when slices are different sizes. Ooh, let's go with D as a dog. C. Steve and Kat, question 4. How are bar charts and Pareto charts?
Pareto?
Pareto.
I don't know. Charts related. Pareto charts are constructed from tossing a coin several times. Wow, I love this. They are identical. It's got to be C.
I
The only
agree.
difference
Yes.
between bar chart and Pareto chart is that the bars in the Pareto chart are ordered from largest to smallest, going from left to right. Okay, number 5. Scroll down a little bit, except it's not saving. Save. Okay. Use the following information. We conclude that population with a hat bar, I don't even know what they called that.
Dude, I have
No, they call it P hat in the video. They did call it P hat. So
Okay, so P hat is normally distributed if NP is greater than or equal to 10. And, oh yeah, right. Okay, so is
Yes.
P the true proportion or the sample proportion?
I
I think it's the true one. What do you think? I don't know.
don't remember. P.
because it said I wrote down that P
My
hat.
estimator for the true proportion.
Hold on. P hat is the
I think-
formula though. Wait a minute. No, it's the, remember, it's,
And I wrote down P hat is the sample proportion, right? Because that's really what the X is the sample
It is.
of
it's X over
the
N.
N. So I would think it is the true proportion.
Yep, it is the sample proportion because it's over sample size. Thank you. Number 6.
Wait,
Wait,
you think it's? I think it's true proportion.
Oh, you think it's true? I
Yes,
think
because
hat
the P
equals,
hat
I
is
think
the
it's
point estimator for the true proportion.
it's the number of people in the sample with the characteristics that we're looking for divided by the total sample size.
Sample.
So because we're dividing a sample size by the number of people in sample, that means it's the actual true proportion?
Yes. That's what I'm saying. It says P hat is the point estimator for true proportion. So if we calculate P hat, then it's going to equal P, which is the true proportion.
Oh, proportion,
I
not
understand that.
population. Not population.
Not population.
The proportion of, okay. Okay. It's the
And
number
I
of
have written down that the P hat
people.
equals the sample proportion. And that's actually what, in that symbols reference that's in our book,
Yeah.
it does say that P hat is the sample proportion or traditional estimator of P.
Wait, say that again.
So P hat is the sample proportion, is what P hat is. So if
Oh,
they're
so it's
asking
not
just what P is, I'm guessing P is the true proportion.
I'm seeing we're referring to P hat the whole time because I'm looking above, but you're right. The question is P.
About P, not P hat.
That's okay. Thank you. I agree. It's true proportion because
Okay.
P hat would be sample proportion.
Okay, and I'll
Okay.
submit first just to make sure. So.
All right. And N would be the
I love this
total
question.
sample size.
Yay, an easy question.
I know.
Okay, I'll take over the next one.
Yeah, sounds good.
If P equals 1/4, what is the smallest N that satisfies the requirement? So I did something fancy schmancy, of course, because I'm in my Excel class, and put these calculations into an Excel spreadsheet, of course, because I love Excel. But this does really make sense, because you figure if P is 0.25, right, and we were supposed to times P by N, our sample size, we need to make sure that it's greater than the number 10. So if you figure I counted 10 times 1/4.
Did they give us a reason why it's 10, or is it just it's just 10?
That's, yeah, just the rule. Yeah, interesting enough. Yeah, nice of them to.
So say N is 40. So 40 times 1/4 equals 10. So it has
You got
to
it,
be
which we need to. You got it. So we have to at
for
least
the
have
one
it be
side.
40.
But
or
let me do
greater.
the other side. All right, and then the other is
Go ahead.
If it
Well,
were
let's say we have 40.
40, and then 1 minus 1/4.
So take 40 times 0.75 would what it would be, right?
Which
Yes.
which equation are you using?
Hi,
So
sorry.
Oh, there you are! Yay!
Oh, hi.
So the two equations that we're looking at are the two equations. Sorry, we're on question 7, Monica. Welcome. Are the two
Okay.
equations that are right there above question 5? Parity. Is that NP, which is greater than or equal to 10, or the N times 1 minus P greater than or equal to 10?
All right. I get, so it has to be 40 because otherwise they.
So yeah, so it's 40. I was wondering if it was 40.
It is. I believe it is 40.
Okay.
Um, hold on a second, guys.
Can I go really fast? We just tell you the answers.
Sure, go ahead.
So number 3 is C. Each slice represents a category.
Yes.
Okay. Number 4 is C. The only difference between bar and chart.
Yes.
Yes.
Okay. Number 5 is true proportion.
Yes.
Number 6 is the sample size.
Yes.
Okay. Oh, sorry.
No, you're okay. I'm glad you made it. We were worried.
Okay.
Okay, so use the following information to answer the next 2 questions. Suppose that N, our sample size is 24, and P is 0.4. What is the mean of P hat, round to the nearest 10th? So this should just be the 0.4, because P and P hats are interchangeable unless they tell us differently.
Okay. Yeah. I'm not sure if they're the same, but when they say the mean, I think it refers to P. So I think it's 0.4. I agree.
What about that formula that told us P equals,
Well, exactly. So P hat equals, right, X divided by N, but they don't give us an X and they don't give us, well, they give us the N, but they don't give us an X.
oh, and so
So
we
we
just,
can't calculate the P.
Yeah, and it says the mean.
all right,
We're assuming that they already did.
Yeah, and it says the mean of P. It doesn't say only P. So I think it's 0.4. Yeah, I agree.
okay.
Okay, now we need to do the fancy schmancy equation.
All right, let me.
So now we have, what is the standard deviation of P? So now we need to go to that standard deviation of P hat, which is where everything is square rooted, and we take P times 1 minus P divided by N.
Okay, I got 0.1. I'm not sure.
And in this case, the P and P hat are both 0.4. And I have a standard deviation of 0.1. Is that what you got, Monica?
Yeah, I got 0.1.
Give me
Hold
a
on, let me
minute,
put in my
please. I have to
calculator.
plug it
No,
in.
take your time. Work through the equation. Yes. Know that your goal is 0.1, though, so far.
Yeah, I work I try to answer ahead because I had something to do today, so I thought I wouldn't be on time, and I wasn't.
That's okay. We're glad you're here.
Except, hold on. So,
Okay, I got 0.1.
Good.
no, the square root of 0.1 is 0.31622.
Oh, okay,
I
so
did the
let's,
square root at the very beginning, like I put the entire thing in a square root and used parentheses on the inside.
So if I do the square root, let me try it again.
So if you use square root, then 2 open parentheses, and then 0.4 times open parenthesis 1 minus 0.4, close
I
parenthesis,
put
close
1.
parenthesis, divided by 24, close parenthesis.
Nope, I got 0.1. Okay, 0.1.
okay. Monica, you want to take over this next one?
Okay, just give me a minute. Okay, number
10.
Okay, Brittany's dating average is 0.300. We want to determine the probability she will get more than 35 hits in her next 100 at bat. So what is P? I wasn't sure. I got 0.35, but using the formula P, let me see.
Because in this case, I think we need to take the P formula that you were talking about, where with the P hat formula. So in this case, they said 35 bats, right? And out of 100. So 100 is our sample size, and 35.
And 35 is N.
Yeah, I have 0.35.
Yeah, I got 0.35,
Wait, what is the
but
equation?
X divided N.
So the P hat equation, yes, is X divided by N, where X is the number of times we want something, right? And where N is our sample size. So it should just be 35 divided by 100.
My question, do you know why they are giving us the average, like the 0.300?
Yes, because that's for the next question down there. Because that's the P. So we just calculated the P hat because they gave us, because essentially they gave us what would normally be the P and the P hat.
Oh, so the
Now
P,
we're taking, now we're adding kind of something else into the equation. We're saying, okay, what's the probability now of this? So let's take what we have and figure out how it differs from what she's about to do versus what her average is.
so what is P? My answer was 0.35?
Yes, 0.350. Oh, 2 decimals. 2 decimals.
Okay.
0.35. Charity and Melody, are you still with
Yeah,
us?
yeah.
We got it.
Sorry.
I'm just doing the next one.
And here's the next one. What is the standard deviation of P?
Okay. I got 0.046, but I'll have to check again. Yeah. I got 0.04582, but 0.456.
0.046. That's what I got.
Hold up.
Take your time, Charity.
For N, am I using 35 or 100? 35 or 100, right?
100 is the sample size.
Okay.
And so for our P hat, you're going to use that 0.35, and P, you're going to use 0.3.
Okay, I got
Oh, wait a minute.
0.04769.
Hold on a second. There's a
Oh, but you don't
standard.
need-
Is there a standard deviation of P hat and one of P? Why does it say the standard
Yeah.
deviation of P hat when we're putting in P?
Are we putting in P or are we putting in P hat?
The formula says P, but I don't know why it's asking this. What is the standard deviation of P hat? I don't know that that means anything.
Oh, yeah. I didn't realize that, but I don't think we have a formula for P hat.
No. All right. Well, we got to do z-score. So yeah, 0.046. Let's do our z-score. Let me see what that formula is.
Z-score is P hat minus P divided
Okay.
the square root of P, parentheses 1 minus P, parentheses divided N.
Let's see. And P hat what was 0.35, right? 0.35. Okay.
I got
So for the standard deviation, it was 0.4. Wait, 0.046.
yes.
Yes.
Okay.
But I think you have to keep the bigger number for the next one because you don't want to round it when we do the calculation for the z-score.
Yeah.
For the z-score, so we put this in the area place, right?
Yeah.
And then what do we have highlighted? That's what I'm confused about.
I think the
All right.
right.
I have my
That she will get more. We need to highlight the right side.
The right side?
Yeah, because we are looking for more.
Okay.
What
So
did you get for your z-score?
105?
Nope.
What?
So the z-score I got was negative 1.09.
Just give me a minute. I got something different. I need to do it again.
But it's because that bottom number, instead of putting it over 0.046, I put it over the longer thing, 0.04585, like a longer.
Okay.
And you
I'm
put
just
that
gonna do
where
it
it's like
again. I did something wrong.
Okay.
Okay, I lost you guys there for a second. Sorry, my connection dropped out.
No.
Welcome back.
Minus 0.3. Just give me a minute. So
What'd you get for your z-score, Kayleen?
I got 0.46, but I wonder if that's not correct. What did you guys get?
No, not that. Not that.
Yeah, that's
the z-score.
deviation.
The next.
The z-score I got 1.0911.
Okay. Yep. And was it negative?
so what is the formula? I'm doing something wrong with the z-score because I'm getting minus 5.54. So that's not right. And I got 6.3.
Let's see if I can hold it up. Let's see. Is
My
this-
Z-score is not negative.
Okay, well, I don't know if you can see this, Monica, but this is the Z-score formula right here.
Oh yeah, that's
Really messy.
oh yeah, it's the same I got, but I don't know why I'm not getting the same answer.
What did you get, Monica?
The first time I got 6.6345 and the 6, and then I got 5.5 something. So it's wrong.
So the bottom thing that you're going to put it over is going to be our answer to the previous question, except that it's not going to
Yeah.
be rounded.
But it's gonna be 0.04582. That goes in the bottom.
Hold on, I have
Am I
this on
right?
my page. Yes, yes. So,
So-
take
so then
on top, take 0.35 minus 0.4 on top.
But no, isn't. Oh, I was doing the standard deviation of P. Okay, that was my mistake. Yeah. Okay, minus 0.3.
Where
Then
did you
divided.
get the mean from?
It's 0.35
Minus 0.3, isn't it?
minus,
Yeah.
I thought it was 0.4.
Yeah, you're right. I was doing the standard deviation instead of. Yeah, so I got 1.091 positive.
All right,
Yeah.
I got something totally different. So hold on a second. How did you guys? Let me see what I plugged in wrong. Just give me 1 second. So the Z-score is supposed to be. Let me go up to the question. Oh, 0.3. Yeah, I put in 0.4. I don't know why.
Oh, okay.
So yeah. So then it should be positive 1.09, right?
So what is
Yes.
it?
Yeah.
0.35 minus 0.3 over 0.04. Oh wait. Yeah, 0.046.
Yes.
That's the equation, right?
Yes.
All right. I don't have my applet open, so I just need to open that really quick.
Okay, I'm still getting 1.111111.
Did you put the rounded number on the bottom?
Yes. Should I not have?
You can't do that. You have to like go out like 4, 5, 6 decimals.
Oh,
When
okay.
you-
What was it? It was 0.0458582.
582.
Okay.
Yeah.
Let me retry. So 0.35 minus 0.3 divided by 0.04582. Okay, I got it now.
Okay, then we have 1.09. And were we looking for greater than? I didn't look.
Yeah, greater
Yeah.
than.
Yeah.
I
So it's 0.379, right? One.
0.1376. So it's 0.138.
So we're rounding. Yes, so 0.138.
Okay, thank you.
For what? For 12?
Or 13.
Yes, 'cause you're gonna go
So-
for
Oh,
13.
okay. I was like, whoa, that's not.
4.138. Okay. Okay.
Does it matter if you put the 0 point, or can you just put point?
I don't know.
I think you
I
can
don't-
just put point. Because I was doing it in the beginning. I was just putting the point.
Okay.
And then you guys convinced me and trained me to put the 0 first. So
Okay, I'll read this one. If the true proportion of people who support a candidate is P equals 0.52, and if N equals 2,000 people are surveyed, we want to determine the probability that the results of the survey will suggest the candidate is losing the election. What is the standard deviation of p hat? Round to 3 decimal places. So,
Okay.
let me put in my calculator now.
Give me a second.
The square root. 152. Oops. Okay, I got 0.01117.
Me too.
Yeah, me too.
Yeah.
So 0.011?
Yes.
Yes.
Okay.
And then what z-score would you use? Hold on, I'm gonna do this equation now.
It's nice that we calculate the first part first and then
Yeah.
add the next in there.
Okay, so we have to figure out P. The P is going to be
0.52.
Is it? When they
Maybe.
said something about flipping something and having 50% votes, I felt like they said you have a 50% chance of.
Oh,
but- Yeah,
you
but
want
we need to
check
figure out
probability that the variable suggests the candidate is losing the election.
yeah, I was wondering if it was 49%.
0.48.
Yeah, or 0.49. I don't know.
0.49.
You mean 0.48?
No, I'm pretty sure it should be, looking at the homework, it should be 0.5, which is a 50% probability. So P hat is 0.5, and then the P is 0.52 that they want to figure out, and then our sample size is our 2,000.
But why it says getting less than 50% of the votes?
Yeah,
That's the key to P hat, is 50% of the vote. So we got to go with 50% is how we figure out P hat. And then
So it
when we put
doesn't
it in
matter
the
if it-
applet, we're only looking at the left side because it's less than.
Okay.
But again, in order to get that 50% P hat, that probability, we take that 1,000 divided by 2,000 to get our 0.5.
so we're just using.
And I think that's what gets
5
tricky, is
SP,
that
or
your P hat can be, I think that's what's tricky is the fact that your P hat can be a percentage and a point, right? It's either 50% or it's 0.50.
I'm confused.
Yeah, me too. So in the applet, we used, I got minus 1.8181.
So my z-score I got for a negative 1.790.
How are you setting up your equation?
I got the same, Kayleen. I understand what you're saying.
Okay. So the P
I
hat
agree.
is 0.5, and then you subtract, and so our value is 0.5, and our mean is 0.52 in this case.
Yes.
We're going to take the 0.5 minus 0.52 and then divide it by the standard deviation that we got in that previous.
So point.
But
And
you-
you said negative, right?
And I have negative, yes.
Yeah,
I have
okay.
a negative 1.7903 is what I got.
Whenever
So
you're doing a probability of flipping something, like flipping a coin or 50%, you have your P hat is always going to be 0.5.
50, you got it, because there's only a 2%, and it's because there's only 2 possible solutions. So same thing here.
Oh,
When we're
okay.
talking about a Republican versus a Democrat, there's only 2 possible answers. So if they were
did
to add
you
a
guys
third in
get
there, then our P would go
negative?
down to like 33. Go ahead, Charity.
Did you guys get negative 1.79?
Yes.
Yay! And we need to add the
Okay.
round to 3 decimals, so add a 0 on there.
791 or because it's
791.
7905.
I have negative 1.7903. So if I were to round it, it would just be 0.
I got negative 1.7905.
Yeah, me too.
It's because you guys didn't put the full number underneath. You have to put underneath that 0.011171392,
I went all the way up
like the big number.
Oh, the entire thing?
Oh,
As much as
I don't
you
have,
can. As much as, I would probably go at least 5, 6 decimals.
Yeah, and that's why I put these equations in Excel, because then I don't have a rounding error. It essentially just takes the equations and does it all by itself. I really should send this to you guys so you guys can cheat too. I don't know if it's really cheating when it's just using what my knowledge is.
okay,
So for the
you-
probability, put that number in the normal, in the probability
it.
applet,
You got
and I
it.
put
So
that
you
in the
wanna
area,
put negative.
right? Oh no, in the
Yeah,
z-score,
oh,
sorry.
in the Z-score, yeah.
So in the
Do I
z-score,
highlight-
Highlight the left.
You're right.
and we're just doing the left, which is less than, right? The probability of
That's where
losing.
Yeah, okay. So 1 point.
So 0.0367.
That's what I
Yes.
got as well.
Yeah, me too.
The 3 decimals, 0.037.
Oh,
Oh, yeah.
Right?
Yeah. Yeah, I had the same mistake.
I know. Sometimes I hate the rounding because I'm like, that's the number the app gives me. It should be right, no matter what. Because I did all the work to get there. I'm going ahead and submitting my quiz real quick.
okay.
Oh, 16. We're missing 16.
Give 100.
Oh, the C-score. Just give me a minute. I didn't put the C-score where I'm supposed to. So the C-score was negative 1.790.
Yeah.
Okay. And then at the end was 0.037.
37.
Oh, 37, yeah. Okay.
And we have 100%.
Really?
Sweet.
Yay. Let me submit it. Make sure I didn't type something in wrong before you go.
Sweet.
Submit. So Monica, before you got here, we were talking about ideas for our project that we need to
Oh, yes.
start thinking about. Do you have some ideas?
I was reading. I really don't understand if we have to like come up with an idea and make a survey, or I don't really understand the project.
It's best not to do the survey, or you have to go. Yeah, I got 100%, because then you would have to go get fill out a special form and do it legally, and there's some requirements to do that.
Yeah.
So we don't really want to do
For
that.
sure.
Okay, so we want information and then do like with that information make all these calculations that we know, or is that what we have to do?
Yeah. At the very first or second week in this class, and I don't remember when, or maybe it's just in the lesson at the beginning of the book, but somewhere there was 2 sample projects that you could look at. So you'll want to look through if I find it, I'll send you an email. You'll want to kind of look at the sample projects. I think that we can make ours look a little bit better. But they were fine. They were fine samples. But I think that that's what you'll want to look at to kind of see what they did. He had mentioned on one of his calls something about how, one idea is to go from place to place and choose a few certain items and then see the difference in price. So he had mentioned something like that. He also mentioned that if he sees another M&M project, he's just going to die, or he didn't say that in his words, but he did say something. I remember him saying something to the effect of not wanting to see that kind of project.
Again.
Like, how many times do I get the yellow M&M?
Okay.
So we don't want to do an M&M project.
That's good to know.
Or Skittles.
So true.
For a change, let's do Skittles. Okay.
But we were thinking that either we would maybe want to measure something. So if, like Kayleen had mentioned, fruit by the foot, if we got a big box of fruit by the foot and we measured a whole bunch of fruit by the foot to see if there's a difference or if they're all exactly 2 feet, that would be an idea. And then another idea is to have us go to Walmart in different states and see if Walmart charges the different prices on, say, 40 different items at 3 different Walmarts, or if the prices are the same within a reasonable parameter.
Oh, that's good. But I will have prices.
You won't be able to do it. You won't be able to do Walmart because it would be kind of.
I have Walmart in Guatemala, but it's in Quetzales. Like it's different.
I think it's going to be so far different, or so much different, that it's not a fair comparison.
Yeah.
So
Well, I think if we were to do hers, we would have to calculate in the exchange ratio of money and everything else. So I think it'd be really, really complicated to factor Monica's. So.
But we have plenty of things for you to do, Monica. So
yeah, there's still plenty of assignments. Yeah, looking at that Word document they gave.
We could see if fruit by the foot is different in Guatemala versus America.
That would be interesting. Fruit by the meter. Maybe it is called fruit by the meter and not fruit by the foot.
I don't know what is that. What are I don't know what is that. Like I was.
Oh, okay. Hang on. Let me go get one.
She doesn't even know what it is.
Yeah, like that's a good idea. I don't know what it is.
It's like fruit snacks. Kids fruit snacks.
That's so funny.
Okay, so it's just a little treat like this. and you open it.
Oh, I think I
And
have
it's
seen them.
essentially just a gummy treat that gets rolled up between
Oh.
some paper.
Yeah, I have seen them. They don't have it in many places, but yeah, I know what it is.
Okay, Kayleen, before we meet next time, your job is to feed your kids 2 of those and measure 2 of them.
I'll 2. Are you kidding me? My kids eat like 2 a day.
Yeah,
Between
and
now
just
and then,
see
I'll
if
measure
they're
half a dozen of them.
exactly the same. Or
Okay.
if
Or if there
there's
is a deviation of a half inch or a quarter inch or whatever it is.
yeah,
Okay.
because if they're exactly the same, it's
So, but what
There's no
It
measure?
might not be worth it. No, you're right.
What measure do you use? Because I use centimeters. I know that you don't use that, so I have to measure in
So I would do
inches.
inches and feet. Yeah.
Just
Inches and feet.
Okay. I know
Is what
you
we're
have. Okay.
all right. Well, if anyone wants to look ahead and see when our official, he said something on the call about, and I felt like it might be this week, that we had to possibly submit a proposal to him, and he has to approve it ahead of time.
oh,
I don't know.
I don't mind working on the proposal real quick because really he says that the most proposals get rejected because it's all about
That's
how
right.
we do our sample size. So I'll
And
just write up kind of what we've talked about, how we would get our sampling for both of these, and that way at least
Okay.
if we submit 2, then we have more of a probability. We have a higher probability of getting it
I think
approved.
one
They're
of the
not.
things one of the things he mentioned to be really careful on, that was a reason that they got rejected, is that they don't word things correctly. So we have to make sure it's, population or the population sample size, or the simple random. I don't even get it. I just have to look
Okay.
at the
Yeah,
little
just
So
chart.
I'll try and type it up like in the next couple days and send it to you guys before the next meeting so we can talk about it at the next meeting.
Okay, sounds good. And maybe I'll look up and see when things are supposed to be due, or when these proposals are due, or maybe I'll go listen to his most recent call if he mentioned anything. I don't know if he had.
Sometimes his calls are so long. I can't take it. I
Yeah.
try to listen.